What's up, everybody? In this video, we're going to cover USACO's 2021 Open Contest at the silver level. Problem number 2, do you know your ABCs? Farmer John's cows have been holding a daily online gathering on the Muzi, like Zoom, I get it. Muzi video meeting platform. For fun, let's start over. What's up, everybody? In this video, we're going to cover USACO's 2021 Open Contest at the silver level. Problem number 2, do you know your ABCs? Farmer John's cows have been holding a daily online gathering on the Moose video meeting platform. For fun, they've invented a simple number game to play during the meeting to keep themselves entertained. Elsie has 3 positive integers, A, B, and C, where 1 is less than or equal to A, which is less than or equal to B, which is less than or equal to C. So they have to be in increasing order or all equal, and they have to be at least 1. These integers are supposed to be secret, so she will not directly reveal them to her sister Bessie. Instead, she tells Bessie n, where n is between 4 and 7 inclusive, distinct integers x1, x2, up to xn. Remember, xn can be 4 or 5 or 6. We might have 4 numbers, 5 numbers, 6 numbers, etc. All of which are between 1 and 10 to the 9th. Just as a real quick note on size, we do not need to use longs for this. The reason why is because if we had, for example, been given A, B, C, and A plus B, if all 3 of these are limited to a maximum of 10 to the 9th, that means A plus B at most could be 10 to the 9th, which would mean over here, A and B together are at most 10 to the 9th. C could at most be 10 to the 9th, which means that A plus B plus C would be at most 2 times 10 to the 9th, which is inside of your integer capacity. It would not be possible to assign values to A and B such that these would all be 10 to the 9th, for example, and 10 to the 9th, because then A plus B would be greater than 10 to the 9th. And that's going to be the case for every single combination of numbers. So short explanation is you can just use ints for this. You don't have to worry about the numbers being too large. Given 4 to 7 distinct integers between 1 and 10 to the 9th, claiming that each xi, which means each of those numbers, is one of either A or B or C or A plus B or B plus C or C plus A or A plus B plus C. This is basically every possible combination of the 3 numbers. However, Elsie may be lying. The integers xi might not correspond to any valid triple ABC. So for example, just as a simple one, if we had like 10, 100, 1,000, 10,000, if they had given us these numbers, there's no way that any combination of these are going to add up to 10,000. If this was A, then yeah, we would have to have like a B of 90 to get the 100. Anyway, given enough numbers, it's going to be possible to construct a situation that there's no possible way to get an A plus B that adds up to all the numbers. Maybe if I did like a sequence of prime numbers, I'd have to think about it. But anyway, Elsie may be lying. The integers might not correspond to a valid triple at all. Technically, they also might correspond to multiple valid triples, and that's what you're going to be responsible for in this problem. This is too hard for Bessie to wrap her head around, so it is up to you to determine the number of triples, ABC, that are consistent with the numbers Elsie presented, possibly 0 if it's an impossible situation. Each input file will contain T, where T is between 1 and 100 test cases that should be solved independently. All right, let's look at what we got here. So input format. Input format comes from the terminal standard in, so you could just read input as typed into the console. The first line, the first input line contains T. That's how many test cases there are. In this case, there's 10 test cases. Each test case starts with n. So for example, this 7 right here is our first n, which is the number of integers Elsie gives to Bessie. The second line of input of each test case contains n distinct integers, x1, x2, x3, up to xn. So in this case, where, for example, this was 7, this is x1, x2, x3, x4, x5, x6, and x7. The next test case has 4 numbers. This is x1, x2, x3, and x4, and that's where it cuts off. Your output, you're supposed to print to output in the terminal, which is just a standard print. For each test case, output the number of triples, A, B, C, that are consistent with the numbers Elsie presented. So if we scroll down here, it says for x equals 4, 5, 7, 9, there are 5 possible triples. Let's kind of just look at this and see what that means. 4, 5, 7, and 9. And remember, we don't know if any of these is A or B or A plus B. It's possible this 4 is A plus B. It's possible this 4 is only A. So we're looking then to see what are some valid triples. So for example, here's a triple. If A is 2, B is 2, and then C is 5, then I've got, here's a 5, that's C. Here's a 4, that's A plus B. Here's a 7, that could be A plus C, for example. Here's a 9, that could be A plus B plus C. 5, 6, 7, 8, 9. Yep, there we go. And then we aren't given B plus C, but if we were given B plus C, that would also be 7. So that is a valid triple because the numbers 2, 2, and 5 will allow us to generate all of these numbers. Also, though, 4, 5, 7. Oops, let me back up. Clean this up a little bit. Okay, so here we go. 2, 3. Okay, so in this case, the 4 in the provided numbers was generated by A plus B. But there's other triples that will work. For example, I could have 4, 5, and 7, where A is 4, B is 5, and C is 7. So now, instead of that 4 being A plus B, this 4 is just A. Instead of that 5 being C, it's B. Instead of that 7 being A plus C, it's A plus B, it's C. So this 9 then, where's this 9 coming from? 4, 5, and 7. Yeah, and then that would be A plus B for the 9. And then we aren't given A plus C or B plus C or A plus B plus C. We could calculate those. A plus C in this case would be 11. B plus C would be 12. Do that right? Yep. And then A plus B plus C would be 16. So that's also a valid triple because these 4 numbers that we started with, 4, 5, 7, 9, can be generated with A being 4, B being 5, C being 7, and then 9 being A plus B. So these are all the possible triples. Now, as far as approaching problems like this, when you see problems like this, my recommendation is to come up with all sorts of combinations. Try different numbers, try different patterns, try to solve them just looking at it. If you look at 4, 5, 7, 9 and you don't know what those are, try to think of a triple. Try to come up with a triple that solves the problem. For example, if I were to say, okay, well, what if A is equal to 1 and B is equal to 3? Then I could get this as A plus B. But then to have 5, I would have to have either a 4 or a 2. Let's do a 4. So if I had C equals 4, then I could have A plus C. For 7, I could do B plus C plus C. Oh, but then there's no way to make a 9 because I can't do 4 plus 3 plus 1 isn't going to be 9. So that's too small. So that doesn't work. Play around with it, get a feel for it. Also, write out the possible combinations you have. A, B, C, A plus B, B plus C, A plus C, and then A plus B plus C. And think about, if I have to have 4 of these numbers, what kind of conclusions can I draw from that? For example, if the 4 numbers I have are these 4, are there any observations I can make as far as I don't have any of these 3 numbers? What could I do with these numbers to potentially generate them? Or if I was given, for example, A, B, and then A plus B, and then B plus C, what could I do as far as trying to figure out the other numbers? Look at a couple combinations of that. Take a minute to think about it. It's a good time to pause the video if you haven't already run through it with paper pencil, and then we'll run through the solution. I'm going to write this out here. So we have A, B, C. I'm not going to write the plus. I'm just going to do A, B, A, C, B, C, and A, B, C. Okay. So an interesting observation. I'm going to switch to a blank page. Because I know that I'm given at minimum 4 numbers, then of these 7 options, A, B, C, A, B, A, C, B plus C, and A plus B plus C, I have to have at least 4. So let's just start picking out combinations. What if I have A, B, C, and A plus B? So in this case, I've got A, I've got B, I've got C, and I've got A plus B. This would have to be the sum of A and B. And if I can verify that this number can be made by adding any 2 of those numbers up, then I know that it works. Likewise, because I know that I have A, B, and C, even if I don't know which number is A, which number is B, which number is C, and which number, more importantly, is A plus B, for example, maybe I can't tell. Maybe these 2 look like they're switched or something like that. I can come up with every possible combination of these numbers. For example, A by itself, B by itself, C by itself, AB by itself, then combinations of them. A plus B by adding these 2, A plus C, B plus C, but then I also have to incorporate AB. So I would have A plus AB, B plus AB, and C plus AB. Now, these are all the possible numbers I could make out of these. Now, if I don't know which one of these is A, B, or C, if I've just got a collection of numbers, I can generate all of the possible combinations. And as long as I know for sure I've got A, B, and C in this set, I guarantee that this thing must also be in the set. And then these should contain all of the potential numbers. Now, that's not so interesting if we know we've got A, B, and C. What if we have a weird combination? Let me clean this up here. All right. What if they don't give us A or B or C, and they only give us ABC, BC, AC, and AB? Now, I could generate A by taking ABC and subtracting BC. If I do ABC minus BC, then what I'm going to be left with is A, just from the rules of algebra. If I take ABC and I subtract AC, I'm going to be left with B. If I take ABC and I subtract AB, I'm going to be left with C, which means that if I were to get the differences of all these, then I once again would be able to find A and B and C. If I were to do this, then I would have ABC as a unique number. I would have ABC minus AB, which would be C. I would have AB, obviously. I would have ABC minus AC, which leaves B. I would have AC minus AB, which would be, the A's would cancel out, and I would have C minus B, which would be garbage. I wouldn't be able to use that. Several of these would be not useful. I would have BC minus AC, which would be B minus A. I would have ABC minus AB, which would be C. Oh, we already did that one, CB. And then I would have ABC minus BC would be A. Let's see, have I gotten all these? I'm sure I've missed one of them here. Let's see, so I got ABC, BC by itself. Oh yeah, we need BC by itself. We need AC by itself. We have AB already. Let's see, and then BC minus AC, BC minus AB would be C minus A. I don't have that one yet, C minus A. Okay, I think that's all the combinations. 1, 2, 3, 4, 5, 6, 7, 8, 9. I believe there should be 10. Okay, so 10 combinations. I've got 4 options for the first choice, then 3, 2, and 1. Yeah, I think that should be 10. Okay, so looking at all these numbers, now we've generated a lot of numbers by getting the subtraction of every possible combination. If we get the subtraction of every possible combination plus the original numbers, so ABC is an original number, AB is an original number, AC is an original number, BC is an original number, those were provided. C was generated by doing ABC minus AB. B was generated by doing ABC minus AC. A was generated by doing ABC minus BC. And then C minus B was, how did I get that one? Was AC minus AB. B minus A would have been BC minus AC, those two. And then C minus A would have been BC minus AB. So we've got every possible combination. Now that I've got every possible combination, I can now look at every possible combination of adding these out. If every possible one of these was chosen as a potential value for A, for example, I don't know which of these numbers I've generated. So let's just say maybe this one's A, maybe this one's B, and maybe this one's C. If I try every possible combination, the total number of combinations I have here should be, let's see, I've got, they're going to be 10 times 9 times 8, which is 970, 720. I'm not sure if I'm doing that right, but it's a very small number of combinations. I feel like if I'm doing combinations, it should be permutations, not combinations, because the order doesn't matter. We have to guarantee that A is greater than B, or A is less than B, which is less than C. But anyway, we're constrained within 720 or less, which means it's actually not that much work. If we were to go through and come up with every possible number we can generate by subtracting, then we are guaranteed that somewhere in this mess must be the values of A, B, and C. If we know that some combination is A, B, and C, then it's simply a matter of picking every possible combination of 3 of these and checking to see whether or not all of these numbers can be generated. So AB can be generated because AB is already in this list. AC can be generated because AC is in this list. BCs can be generated because it's in this list. B, BC, and ABC can be generated because that's in the list ABC. Now, if I pick every possible combination, working backwards, so for example, let's say like I picked this, this, and this, thinking this is my A, my B, and my C, which would be a mistake. But let's say like that was the case. Then if I think that the first one's A, then I would have this as my A, I would have this as my B, I would have this as my C. Then I would have A plus B, which would become CB. I would have A plus C, which would be C plus B, or A plus, sorry, this actually should have been CAB. A plus B, CAB. If I'm adding this one and this one. If I add the first one and the last one, would be CB, and then AB and B would become ABB. And then I can check and see if this triple works. So if I chose this as my A, this is my B, and this is my C, then that generates these letters. I then would have to confirm that all of these values have been generated. Oh, and I actually have to have one more, which is A plus B plus C, which first, second, third would be C, A, B, B. If there are any values in this set that aren't present in the numbers I generated when I checked to see if this was my A, B, and C, that would prove that these are not valid values. And these are all the possible values that could exist, because I've subtracted every possible combination together with the original combinations, which means whatever these numbers produce, those are the numbers. A, B, and C must be among those numbers. And it's because of the fact that if I look at, let's back this up here. If I look at every possible combination, I'm gonna go A, B, C, A plus B, A plus C, B plus C, and A plus B plus C. For any set of 4 of these, no matter what the set of 4 is, if I try subtracting every possible combination, I will generate A, B, and C. We already confirmed that with this, because ABC minus BC is A, ABC minus AC is B, ABC minus AB is C. If we picked a different combination, for example, let's say like I had B and then these guys right here, then I've got B, which is provided already. But how do I get A? I'm going to get A by doing AB minus B, and I can get C by doing AC, BC, BC minus B would give me C. So AB minus B gives me A, BC minus B gives me C. Once again, by subtracting every possible combination, I will generate A, B, and C. And it's a good idea to test this out if you're not feeling comfortable with how this mechanic works. Try different combinations. What if, for example, I have 2 of these and 2 of these? How do I get A? I would be able to get A by doing AC minus C, and that would give me A. There's no combination you can come up with where if you have at least 4 of the numbers, we can't generate all of A, B, and C by some combination of subtraction. If I have this, let's actually switch this one. What if I have this and this? AC. Yeah, see, if I have this or this, if I have either A, B, or AC, I could subtract B or C and get A. And if I have one of these missing, and I only have BC, then ABC minus BC would give me A. So let's look at this with actual numbers, because it'll make more sense when you see the actual numbers in play. If I've got 4, 5, 7, 9, 4, 5, 7, and 9. Again, I don't know which of these is A or B or C or A plus B or C. What I'm going to do is I'm going to subtract every possible combination. So, for example, 5 minus 4 gives me 1. That's a potential value, because again, I don't know whether or not this is A, B, C, or some combination. But if I have a 4 and a 5, I potentially might have a 1. I might not. I don't know. 7 minus 4, I potentially might have a 3. 9 minus 4, I potentially might have a 5. I, in fact, already have a 5. We don't need to add anything we already have, because we're going to allow for duplicates here in a minute. So that's 5 minus 4, 7 minus 4, and 9 minus 4. 7 minus 5 would be 2. 9 minus 5 would be 4, which we already have. And then 9 minus 7 would be 2, which we already have. So these are all of the possible values. I know that A, B, and C must be among these numbers. And furthermore, I know that whatever I pick for A, B, and C, some combination must be able to generate 4, 5, 7, and 9. So let's just randomly pick values for A, B, and C. A, B, and C, remembering they have to be an increasing. So if, for example, let's say like I picked 2, and then let's pick 5, and then 9. If these were my values of A, B, and C, then I would generate every possible combination out of those values that I just picked. A, B, C, A, B, B, C, A, C, and then A, B, C. So A would be 2, B would be 5, C would be 9, A plus B would be 7, B plus C would be 14, A plus C would be 11, and A plus B plus C would be 16. I would then need to verify, are all of these numbers in that set? And you look down here, I don't have any 4s. What that means is that if A were 2, B were 5, and C were 9, I could not generate a 4, which means that A cannot be 2 and also have B be 5 and also have C be 9. That's not a valid combination, because there's no combination of those numbers that would produce 4, 5, 7, 9. And we can try that for every possible combination of A, B, C using these above numbers. If you count here, I've got 1, 2, 3, 4, 5, 6, 7. I've got 7 possible numbers, which means at most I have 7 times 6 times 5 combinations, which is, what is that? 7 times 5 is 35 times 6, 70, 140, 210 combinations. It'd be even less than that too, because again, they have to be in increasing order. But within that many combinations, it's a very small number to have to check. 210 checks in order to be able to verify whether or not 210 possible combinations is a very small number of combinations to check. That'll be well within time complexity. Let's try the same thing with a valid set, because we can see the valid sets below. Let's do 225. Now, 225 is significant because we've chosen the 2 twice. It is possible to have values that are the same. So if I have A is 2 and B is 2 and C is 5, that still is okay. I don't have to have all of the numbers, and I am allowed to have these numbers more than one time. The question is there some combination of these numbers up here that will then produce all of these numbers? So let's find out. A by itself is 2, B by itself is 2, C by itself is 5, A and B is 4, B and C is 7, A and C is also 7, and A, B, and C is 9. So then we look, is 4 in the set? Yes. Is 5 in the set? Yes. Is 7 in the set? Twice, actually. Is 9 in the set? Yes. What that tells us is if A was 2, B was 2, and C was 5, then it's possible to generate 4, 5, 7, and 9, which are the provided numbers that we were given. Because of the fact we can see that it's possible to generate 4, 5, 7, and 9, that means that 2, 2, and 5 are in fact a valid triple. And that's why that's listed here. So these are the valid triples they came up with. And if you look at these valid triples, none of them are using numbers that aren't in this original set, because we know for a fact that if we were to subtract every possible combination of the initial starting numbers, that we must in this set have A, B, and C, which means it's not possible to have an A, B, and C that is not in that set, because there's no way we could have done every possible subtraction combination and not have generated A, B, and C, because of the fact we're given 4 numbers, and because we know those 4 numbers are members of the set of A, B, C, A plus B, B plus C, A plus C, and A, B, C. Let's try one more irrelevant one. Let's do 2, 2, and let's do 1, 2, and 2. A equals 1, B equals 2. Actually, we already know that's not going to work because 9 is too large. Let's do C equals 9, 8, 7, 6, 6. Okay, so I'd have A equals 1, B equals 2, C equals 6. A plus B would be 3. B plus C would be 8. A plus C would be 7. And then A plus B plus C would be 9. Okay, so we check all these numbers. Is there 4? Oops, nope, I didn't have a 4, which means that 1, 2, and 6 are not a valid triple. And again, you can see they're not listed here. Let's do one with the larger values to see how that works. It's 4, 5, 7. 4, 5, and 7. But we can actually just eyeball that, and we can see that 4 plus 5 generates the 9, and then we're good because we're given 4, 5, 7, and then 9. And this will be the case for every combination. So some of the triples are going to be using these difference numbers. When they use the difference numbers, that implies that these are combinations of A and B already. That these are the A and B that we'll find through subtraction. On the other hand, if those initial numbers 4, 5, and 7 are used as part of the A, B, and C, then what's going to happen is you're going to have numbers that get generated that are larger than your maximum. For example, A plus B plus C, if I have 4, 5, and 7, is going to be 16. But again, that's totally fine as long as we're able to generate a 4, which would be the A, as long as we're able to generate a 5, which would be the B, and as long as we're able to generate a 7, which would be the C, and as long as we're able to generate a 9, which would be A plus B. Then whatever these numbers come out to doesn't matter because I've verified that that works. So we're going to break this down real quick into an algorithm. For any one of these number sets, we start by loading in the number set. Let's go ahead and just do 4, 5, 7, 9. So we get 4, 5, 7, and 9. We load those into some sort of a container. We then have to add to the container every possible difference of any combination of 2 of them, provided that difference is greater than 0. So again, we just did that, and I should have paid more attention. But so then 5 minus 4 would be 1. 7 minus 4, let's do it again, would be 3. 9 minus 4 would be 5, which we already have, so we shouldn't add twice. 7 minus 5 would be 2. 9 minus 5 would be 4, which we already have, and 7 minus 9 would be 2. We generate every possible number that we can get, including our original numbers, including the differences between any pair of numbers. Then what we're going to do is we're going to set up a for loop. we have for A in numbers, essentially if this is called numbers, for B in numbers, for C in numbers. So going through every possible A, every possible B, every possible C, and again, not worrying if they're the same value. You are allowed to repeat a number. I'd recommend putting these in a set in order to make that easier. You also could put these in a list and just make sure the item isn't in the list prior to adding it. That either way would be fine. I would recommend a set because your lookups are going to be quicker. Once you got that, we're iterating through it for every A in numbers, for every possible B in numbers, for every C in numbers. If and only if A is less than or equal to B and B is less than or equal to C. If those numbers are increasing order, then you generate every possible combination, combos, equals the list of A, which you have, B, C, A plus B, A plus C, B plus C, and A plus B plus C. Once we generate that list, we want to iterate through all of the original numbers, not all of the numbers including the 1, 3, and 2, but all of our original numbers. Maybe if I load this, if this is my numbers, and we'll have to keep those distinct. If my file was 4, 5, 7, and 9, then my numbers are 4, 5, 7, 9, 1, 3, 4, or 1, 3, 2. If this is my file, then what I'm doing here is I generate my combo, and I have to make sure all numbers, all nums, all file values must be in combos. You can read any of that chicken scratch there. Anyway, we generate the combination. So start with your data in your file, create numbers, which has all of the numbers that are in your file together with all the differences of every possible combination of numbers, making sure we don't have any repeats. You don't want to have any duplicates or else it just runs slower. For every A in numbers, within that, for every B in numbers, within that, for every C in numbers, we'll give you every possible combination of A, B, C, starting with A equal 4, B equal 4, and C equal 4, and then C is going to progress through. If A is less than or equal to B and B is less than or equal to C, we generate every possible combination of these A, B, and C that we are assuming might be values of A, B, and C. And then what we have to run through is we have to run through all of the file values, the original values from the file, making sure that every single one of them is in our combos list. Because if I know that A, B, and C must be in here, and I'm trying every combination of A, B, and C, then if I'm looking at every combo I can generate with that set, it must be the case that all of these numbers, 4, 5, 7, and 9, are in this combo. Because those numbers have to be generated by A, B, and C. If we can't generate those numbers by A, B, and C, then it's a bad triple. Anytime that happens and you verify that all of the original values in your file are in this combo, every possible combo set that you've generated here, then you can just have some counter do a plus plus. And then at the end, you just output the counter. So let me see here, switching back over to here, looking at this one more time. All right, looking at this one more time. So we're gonna load in the original test case. For each of the test case, you read an N and all the numbers. Doesn't matter if you have more than 4. Most of the test cases I did before, same rule applies. Get all these numbers, come up with every possible difference. In this case, all that's gonna do is add 1, and there's already a 1. Come up with every possible difference, add them into a secondary set, look at every possible combination from that secondary set for A, B, and C, generate what would be A, B, C, A plus B, A plus C, B plus C, and A plus B plus C, generate all those values into a list, and then make sure that all of the originally provided values are in that list. And if they are, then you've got a good triple, add 1 to the counter and output the counter. All right, that's how it works. Good luck coding it, and I'll talk to you in the next one.